See, next one. In the last class, we discussed about the types of strain. That is, number one, we are having the longitudinal strain. Longitudinal strain. It is defined as change in length to the initial length or original length to the initial length. Okay, and then bulk strain. Bulk strain. It is change in volume to initial volume divided by initial volume. Okay. Next, tangential strain. Okay. Change in shape or we can say dimension by initial dimension. Initial dimension. That is dl by L. That is dV by V. That is theta by L. Okay. Once all of you open your material, ఒకసారి మెటీరియల్ ఓపెన్ చేయండి వాల్యూమ్ 3 చేశారా దివ్య ఆకాష్
ఓపెన్ చేశాను సార్
ఓపెన్ చేశారు కదా see the page number 71
yes sir
page number 71 okay there you are having shearing strain you can see the diagram this small value that is if we consider a cube like this okay there will be a small change in the shape this one. This angle we are considered theta or phi okay this small change we are calling delta x this value we are calling dx this one it is the length opposite by adjacent opposite by adjacent okay before that page number 69 we are having the stress you can see okay in every stress we are having the force by area okay force by area only okay after this strain we are having the types of moduli okay after these types of moduli I'll go to the this one stress strain curve okay fine generally according to the Hooke's law within the elastic limit stress is directly proportional to strain okay by removing this proportionality we are keeping a constant which can be called as modulus of elasticity. Modulus of elasticity E times strain. So modulus of elasticity, I can write it as stress by strain. Depends upon the type of the strain, we are having the types of modulus. Strain will be of three types. This is number one, two, and then number three. Okay. Longitudinal strain, bulk strain, tangential strain. Okay. With respect to the longitudinal strain, we are having Young's modulus. Okay. Young's modulus. Young's modulus. Young, it is the name of the scientist. That is longitudinal stress by longitudinal strain. Longitudinal strain. That is Y is equal to F by A by longitudinal strain means dl by L. That is Y is equal to F by A times L by dl. Okay, that is the formula for Young's modulus. Remember this formula. Okay. Next, with respect to the bulk strain, we are having bulk modulus. Bulk modulus. It is indicated by K. Okay, that is volumetric stress. Volumetric stress by volumetric strain. Volumetric strain, that is K equal to F by A. Volumetric strain means change in volume by initial volume. Antena? Hello? V by dV.
Yes, sir.
Yes, sir.
And then చూడండి వాల్యూమెట్రిక్ స్ట్రెయిన్ మనకి ఇంత ముందు వచ్చింది చూడండి dV by V. అయితే in this one I can write it as, you can see here, F by A, force by area, I can write as pressure, P into V by dV. Okay, sometimes what will happens, as pressure increases, okay, volume will be decreases in the isothermal process. Okay, what will happen, as pressure increases, volume will be decreases. Okay, okay, in that case we can write it as K equal to minus PV by dV. Okay, minus PV by dV. Okay, and after this bulk modulus, okay, there is a property called compressibility. Compressibility. Okay, generally it is indicated by beta. That is reciprocal of bulk modulus. Beta equal to 1 by PV by dV. Compressibility will explain how much the volume of the object is compressed. How much of the volume is compressed. That is beta equal to dV by PV. dV by PV. Okay, small factor is there. And then third one, it is with respect to tangential strain or shearing strain, we are having a rigidity modulus. Okay, rigidity modulus, that is rigidity modulus, which is indicated with eta. Which is indicated with eta. Eta can be written as shearing stress by shearing strain. Shearing, or we can also write tangential stress divided by shearing or tangential strain. Okay, that is eta equal to f by a by dx or delta x by L, or in some textbooks they will write as f by a by theta, that angle. So f by a times L by dx, L by dx. Okay, okay, if I can see this one, okay, okay, remember the formula for the rigidity modulus. Okay, write down types of moduli. Put the side heading as types of moduli and write down. Okay, now completed.
Yes, sir.
So once back page. Done, sir.
Okay, now completed.
Yes, sir.
Yes, sir.
That అయిపోయిందమ్మా. Okay. Over.
1 minute, sir. Yes, sir.
Okay. Now. Next one. In the Young's modulus, first application. Application 1 on Young's modulus. You can see. Suppose if two wires are connected in series, are connected in series. Say for example, let us consider I am having a wire. AB is a wire. Okay, having an Young's modulus as Y1 and length as L1 and area as A1. Okay, okay, fine. With the same area, okay, with the same area of cross section, I am having another wire having a length L2, Young's modulus M2, A2, and area as A. Both are having the same area. Both are having the same area of cross section. Then I want to find the what will be effective Young's modulus if two wires are connected in series. Okay, see up to here it is one wire. AB is one wire and BC is another wire. Okay, okay, that is whatever the stress I am applying. Okay, stress acting on the first wire AB is equal to stress acting on the second wire. That is, I can write as stress of AB is equal to stress of BC. That is equal to total wire. If I consider the total system AC, sorry, F by A, stress of AC. Stress will be the same. Antenna. So total elongation is equal to elongation along AB plus elongation along BC. Chepacha, can I say? Chandrakant, Nikita,
Yes, sir.
okay? Okay, elongation means which we can also indicate with DL or DX. Which we can indicate with DL or DX. Okay, we are having the formula. We are having the formula since Y is equal to F by A divided by DL by L. That is nothing but F by A times L by DL. Instead of this DL, we are writing it as E. We are writing it as E. So that is F by A equal to, sorry, Y equal to F by A times L by E, right? So I can write as E is equal to F by A into L by Y. By using this expression, okay, we got that it is EAB plus EBC. So elongation of AB I can write as F by A because stress is constant. Okay, L1 by Y1 for AB wire we consider the length as L1 and Young's modulus as Y1. Okay, okay, fine. And for BC, that is F by A times L2 by Y2. Right, Cha? Hello.
Yes, sir.
For AC, that is, this is the total elongation. So I can write the total length. What will be the total length? AB length means L1, BC length means L2. Okay. Whenever I combine these two wires, Or if I consider AB and BC as one wire, then what will be the total length? What will be the total length? Dhanavirika, Om Lakshmi.
L1 plus L2.
L1 plus L2. And then,
Yes, sir.
so here I can write it as F by A times L1 plus L2 divided by Y effective. Throughout the equation, I will take F by A common and then cancel. Okay, so we'll get L1 plus L2 divided by Y effective is equal to L1 by Y1 plus L2 by Y2. From this, I can get Y effective. Take LCM. We'll get it as Y effective. So L1 plus L2 by Y effective is equal to Y2 L1 plus L2 Y1 divided by Y1 Y2. So Y effective is equal to Y1 Y2 into L1 plus L2 divided by Y2 L1 plus L2 Y1. Suppose let us consider, okay, case 1, it is if L1 and L2, both the wires are having the same length, then Y effective is equal to Y1 Y2. Numerator will be 2L. Denominator will be Y1 plus Y2 into L. Avuna? Antena? That is your first application. If the rods are in series, okay, we are having the effective Young's modulus. Y effective, this is the formula. Okay, this is the formula. I think open your module page number 73. Page number 73. చేశారా? హలో,
Yes, sir.
అవునా? ఉందా చూడండి పేజ్ నెంబర్ 73లో. ఓకే, ఓకేనా? కంప్లీటెడ్. Okay. Similarly, if the rods are connected in parallel, suppose second one it is, if the wire or rod are connected in parallel, if the wires are connected in parallel, that is, let us having a wire. Okay, fine. This wire it is, here it is A, and this wire is having a length L, okay, and area is 1, Young's modulus as Y1. Okay. Okay, that is area is A2, Young's modulus is Y2. It is same. Okay, here we are considering the two sides. It may be same or it may be different also. No issues. Okay, then whenever I apply a force, then what will happens? Elongations along AB is equal to elongation in the CD. Okay, that will be equal to total elongation. So total stress applied on the system is equal to stress acting along AB plus stress acting along CD. అంతేనా? అయితే ఇక్కడ చూడండి, ఇంతకుముందు ఎగ్జాంపుల్లో if the two wires are connected in series, okay, whatever the stress I am applying, stress acting on the first wire or AB is equal to the stress acting in the second wire, that is BC. But whereas in this case, when the two wires are connected in parallel, okay, the stress acting on the system is equivalently divided. Okay, so here I can write as, since we are having the formula Young's modulus, that is force by area by, okay, change in length by initial length. So F by A times L by E. Okay, here I want to find the value of F by A. See, here I need to substitute. That is Ey by L. Ey by L. Right? Hello? Ma antena? Hello? Right? Okay. Whatever the force F is equal to, we can write it as, since areas are different, so we can write it as, force acting on the system is equal to, F is equal to force acting along AB plus force acting along CD. Force means I can write as F is equal to Eya by L. Eya by L. So along AB, okay, elongation Y1 A1 by length L. Elongation CD Y2 A2 by L. If I consider the total AB and CD as one system, the total elongation is E Y effective times total area. I can write it as A1 plus A2. A1 plus A2 by total length L. Since elongation along AB and elongation along CD is equal to E, throughout the equation E will get cancelled. So Y effective into A1 plus A2. See, in the denominator, L will also be cancelled. Antena? Y1 A1 plus Y2 A2. Right? Divya, Mohita, అంతేనా? చూడండి, ఉదయకాంత్, నిఖిత,
Yes, sir.
అంతేనా?
Yes, sir.
EAB and ECD equal to E కదా, divided by length same, both sides it will get cancelled. So Y effective is equal to Y1 A1 plus Y2 A2 divided by A1 plus A2.
A1 plus A2.
ఇందాకట్లాగా కేస్ 1 అని తీసుకుందాం. దట్ ఈస్ ఇఫ్ A1 ఈజ్ ఈక్వల్ టు A2, దట్ ఈజ్ ఈక్వల్ టు A.
Y1
సో
plus
Y
Y2.
effective ఈక్వల్ టు Y1 plus Y2 divided by 2. అది చూడండి, మెటీరియల్లో చూడండి, సరిపోయిందా? ఇఫ్ ద టూ డాట్స్ ఆర్ కనెక్టెడ్ ఇన్ ప్యారలల్.
Yes, sir.
ఓకే, ఓకే, ఫైన్. అది నెంబర్ 1. Okay. Next one, it is, turn the page number 74. we are having another application, that is elongation of the rod due to its own weight. Elongation of the rod due to its own weight. See that application. కనిపించిందా? అయితే see here we can say that let us consider a wire. Let us consider a wire. Suppose this wire length it is L. This wire length it is L and it is having a mass M. Correspondingly, the weight of this wire will be mg, which is acting vertically downwards. Which is acting vertically downwards. Okay. Okay, fine. Now, whenever I apply a stress, then there will be a change in the length. Avuna? Hello? Let us consider after applying the stress, the length of the wire changes by here. That is approximately this is the change in the length. I will consider it as dl. Okay. Before applying the stress, we are having the length of the wire as L. After applying the stress, okay, we are having the length of the wire as this much. That is, there is a small change in the length. Since we know that Young's modulus equal to F by A times L by E. See, here we got it. Y is equal to F by A into L by E. So the same formula I am using it. F by A into L by E. I need to find elongation. So F by A into L by Y. L by Y. Okay. Okay. Now I am finding this small length dl. Okay. This small length dl, I am finding it. Okay. Before finding, okay, entire this wire at every point, density will be the same. So I will consider the linear density. That is unit length. For the string of length L, okay, okay, mass it is M. That's why we wrote it as mg. For the small length, I am considering it as mass as m dash, or you can consider dm. Okay, preferably I will consider dm. For the small length, how much length of the wire is increased, that much I am considering the mass as dm by dl. Can I write? Am I right, sir? So we can write as dm is equal to m by l into dl. Avuna? Okay na? Okay, fine. See here, this m, what we are doing it is in terms of weight means, okay, this one I can write it as mass by length. I can write it as weight by length, that is mg by l times x by a, that is mgx by area into length. Area of a cross section, okay, that is nothing but L into x. Okay. Okay. For this small mass, we have it as m by L into dl. If you multiply by g on both sides, mg by L into dl. So this is the weight of the increased part or small part. This is the total wire mg by L, w by L, okay, and times the length of the small part. Okay, so here we can write it as, for a small area of cross section, for an area of cross section, okay, A, we are having the we are having we are having the length as L. Okay, for small area of cross section, we are having a length as dl. So for this small area of cross section, I want to find, since y equal to f by a times L by E. E means elongation, that is f by a into L by y. First, I am finding the small area. Okay, the small area. Okay, fine. For this small area, we can write it as surface density equal to, okay, mass per unit area. Similar to the linear density, we'll have the surface density. Okay, that is m by a is equal to dm by da. dm by da. So da, that is dm into area by mass. dm da equal to dm by a. Okay, okay, from above we got dm as m by L into dl. M by L into dl into area by mass, that is dA is equal to area by length into dl. Area by length into dl. Okay, okay, from here we can write it as L by A, from the definition F by A into L by E. So L by A is equal to EY by F. So A by L equal to F by EY. F by EY. F by EY. That is F by EY into DL. F by EY into DL. Okay. Okay, fine. Okay. This application we'll see later. Yeah. This application we'll see in the next class. We'll see. Next one, turn the page. I think in the page number 78 at the bottom, you can see page number 78. At the bottom, we are having the rigidity modulus. Rigidity modulus eta. Can you see?
Yes.
మా కనిపించిందా? అవునా, రిజిడిటీ మాడ్యులస్ అక్కడ చూడండి, డయాగ్రామ్ చూస్తే మీకు క్లియర్గా అర్థమవుతుంది. అవునా, పేజ్ నెంబర్ 79లో మీకు ఫార్ములా కూడా వేసారు చూడండి. ఓకే, అండ్ దెన్ టర్న్ ద పేజ్, దట్ ఈస్ పేజ్ నెంబర్ 80. We are having the bulk modulus. Bulk modulus. Since we know that bulk modulus K equal to PV by dV. Okay. As I told you, suppose in the isothermal process, as pressure increases, volume will be decreases. Due to that, they will keep as minus sign. Okay. Or as volume increases, pressure decreases. Okay. That negative sign indicates the decrease in volume on increasing pressure, or on no, sir, on increasing volume there will be a decrease in the pressure. There will be a decrease in the pressure. Okay. There will be a decrease in the pressure. Okay, fine. Now here it is that, okay, here it is that the point of concentration is, we are having the bulk modulus. Now I want to find the, suppose I'm having an C. Okay. If an object is at a depth h, is at a depth h. Okay. I want to find the, what will be the uh, what will be the change in volume. That is, whenever an object is placed at a depth h, we can write as pressure equal to atmospheric pressure plus rho gh. Right, sir? On the surface means we can write it as rho gh. Okay, at a depth h means we can write as P naught plus rho gh. Okay, so let us consider initially, okay, minus of P naught plus rho gh times volume of the object, by dV. So dV, change in the volume, I can write as minus of P naught plus rho gh into volume by K. K means bulk modulus. K means bulk modulus. Okay. Here volume is decreased, so we are writing as minus T. Okay. With comparison of rho gh, if P naught is very, very less, then I can say that it is rho gh into V by K. Rho gh by K. And then we are having isothermal modulus, isothermal bulk modulus, and adiabatic bulk modulus, which we have studied in the thermodynamics already. Chadukunnama. Isothermal modulus, adiabatic modulus. Okay. And then next point, it is reciprocal of bulk modulus. It is compressibility. Here they indicated with C. Now, can you see? Can you see?
Yes.
Okay. These are the applications and types of modulus. Okay. అయితే మీకు ఇక్కడ ఎవ్రీ అప్లికేషన్ కింద కూడా, ఓకే, ఎవ్రీ అప్లికేషన్ కింద కూడా మీకు ఎగ్జాంపుల్స్ ఇచ్చారు చూడండి. అవునా? రైట్ ఫ్రమ్ పేజ్ నెంబర్ 74 ఆన్వర్డ్స్ యూఆర్ హ్యావింగ్ ద ఎగ్జాంపుల్స్. ఓకే. ఆ ఎగ్జాంపుల్స్ కూడా మనం డిస్కస్ చేద్దాం. ఓకే. ఎందుకంటే జేఈ మెయిన్స్లో ఈ చాప్టర్ నుంచి, సాలిడ్స్ నుంచి ఒక్కొక్క క్వశ్చన్ గ్యారంటీకి వస్తుంది ప్రతి ఇయర్. ఎవ్రీ ఇయర్ 1 క్వశ్చన్ గ్యారంటీ. ఓకే. వన్ ఆఫ్ ద స్కోరింగ్ చాప్టర్ ఇది. ఒక 4 మార్క్స్ మీరు కొంచెం మన ఫార్ములా గుర్తుపెట్టుకుని ఏమి ఇచ్చారని చేసుకుంటే ఇది మనకి స్కోరింగ్ చాప్టర్. ఓకే. అందుకని okay, fine, that is number 1. And number 2, in the page number 73 only, before the wires are connected in series, page number 73 lo chudandi, inda తీసారా? తీస్తే దానిపైన అప్లికేషన్ ఇచ్చారు చూడండి. ఓకే. సమ్ E2 ఈక్వల్ టు E1 ఇంటూ 1 మైనస్ రో బై డి అని. అది యాక్చువల్లీ సెరల్స్ ఎక్స్పెరిమెంట్ చెప్తాను, అది కూడా చెప్తాను.
ఓకే సార్.
ఓకే, సెరల్స్ ఆపరేటర్స్ తోటి అప్పుడు చేస్తే మనకి క్లారిటీకి వస్తుంది. ఓకే అమ్మయ్య. అయితే ఇది మొత్తం ఫైన్ బల్క్ మాడ్యులస్ అండ్ దెన్ టైప్స్ ఆఫ్ మాడ్యులస్ దాకా వచ్చింది.
ఫ్రిక్షన్ కనెక్టింగ్ బాడీస్ బ్లాక్ అండ్ బ్లాక్ కూడా ఉంది కదా సార్ ఎగ్జామ్కి.
బ్లాక్ అండ్ బ్లాక్ ఇవ్వను.
ఓకే సార్. అంటే దాంట్లో
ఓన్లీ ఇంక్లైన్ ప్లేన్, పుల్లీ, స్టాటిక్ ఫ్రిక్షన్, కైనెటిక్ ఫ్రిక్షన్.
ఓకే సార్, థ్యాంక్ యూ సార్.
ఓకే, అయితే కాకపోతే నేనేమనుకున్నానంటే ఈ వీక్ సరిగ్గా క్లాసెస్ జరగలే కదా, మళ్ళీ ఎఫ్పిడి సిఆర్ పెడదామా అనుకున్నా.
అంటే మేము ఆల్రెడీ ఫ్రిక్షన్ ప్రిపేర్ అయ్యాము సార్.
అదే నిన్న మీ మూమెంట్ చూసి అదే అనుకున్నా. ఓ వెరీ నైస్, లెట్స్ గో టు స్టాటిక్ అండ్ కైనెటిక్ ఫ్రిక్షన్ అనుకున్నా, అండ్ ఇంక్లైన్ ప్లేన్
అవన్నీ ప్రిపేర్ అయ్యాము సార్. జస్ట్ బ్లాక్ అండ్ బ్లాక్ కొన్ని డౌట్స్.
బ్లాక్ అండ్ బ్లాక్ అది కొంచెం ఇదిగా అంటే లాజికల్గా థింక్ చేయాలి. మనకి అది షార్ట్ కట్ లాజికల్గా ఎట్లా చేయాలి. అదే మండే ఏ పుల్లిస్తానా
ఫ్రిక్షన్ పుల్లీస్ కూడా ఉన్నాయండి. అవ్వలే కదా సార్
ఇవాళ చెప్పేద్దాం.
ఓకే సార్.
ఓకే, అయితే ఇక్కడ మనకి ట్రాక్ 2లో మీకు ఎక్కడి వరకు అయింది, దీంట్లో మీకు ఎగ్జాంపుల్సే ఎక్కువ ఉంటాయి చూడండి, ఎగ్జాంపుల్సే ఎక్కువ ఉంటాయి. నెక్స్ట్ వన్ నెక్స్ట్ ఇట్ ఈస్ stress strain curve. Okay, that is page number 71. You can see stress strain curve. For IP it is most important. Okay, most important 4 mark question. Okay, చాలా తక్కువ సార్లు థియరిటికల్ క్వశ్చన్ అడిగాడు దీని మీద. ఓకే, ఒక 3 times 4 times అడిగాడు JEE మెయిన్స్లో. ఓకే, that means whenever we draw a graph between stress versus strain, on x-axis we are having the strain and on y-axis it is stress. అయితే here we are considering that, okay, I am considering longitudinal strain and longitudinal stress. Okay, that is whatever the strain I am considering, the same type of stress I am considering on y-axis. If I consider volumetric stress, here it is volumetric strain. Or else if I consider shearing stress, this is shearing strain. Okay, whatever the kind of stress I am considering, same kind of strain it is there on x-axis. It is there on x-axis. Within the elastic limit, according to the Hooke's law, within the elastic limit, stress is directly proportional to strain. That means that as stress increases, strain will also be increases. Chappacha? Okay, from the origin to the point A, it is the elastic limit. Okay, so in this limit, we can write as stress is directly proportional to strain. Okay, after the elastic limit, if I apply still more stress, okay, what will happen? Initially the object will changes its shape. The object will changes its shape. Okay, fine. Here we are having a graph like this. Okay, you can see the point B. Up to the point B, what will happen? Up to point A, it is elastic limit. If I still increase, what will happen? Due to this nature, elastic nature, somehow it will come. Up to point A, it is proportional limit, and B, it is the elastic limit. B is the elastic limit. If I still after the elastic limit, if I still increase the force, then what will happen? Initially, the object will changes the shape, can be called as yield point. The object at the point or position at which the object changes its shape can be called as yield point. And then after that, it is, if we still increase the force, then what will happens? Okay, it will have an, okay, it will have a, or it will be passes through an breaking point. At some point, what will happens? The object will breaks. Okay, D, it is the intermediate point between the yield point, change of shape, and the breaking point. Okay, in generally, in the objects, D will be much more faster. D will be much more faster. Okay, so the graph between stress and strain, if you see the slope of the graph, that is nothing but stress by strain. Stress by strain, that is nothing but modulus of elasticity. Stress by strain ante chepocha. See the page number 71, Hooke's law and stress strain curve. In that stress strain curve, underline the point that area under stress strain curve gives strain energy per unit volume. That is, stress into strain means strain energy per unit volume. Underline that point, most important. Many times we'll use it. Okay. And in the next class, we'll discuss about this one, elastomers and elastic hysteresis. That is theoretical concept only. Okay. Very rarely, I think one time they asked on the elastomers. One time or two times they asked on the elastomers. Okay. And then in the next class, we can discuss the Poisson ratio and the strain energy. Elastic potential energy, this derivation, and then Springer. Mostly in the next class, okay, we will complete the concept of these properties of solids. Okay, Sunday we'll have a session. Okay, if internet is having a problem, then I will record the video and I will send in the group.
Okay, sir.
ఎందుకంటే ఇప్పుడు మనం ఇక ఛాన్సెస్ అనేది తీసుకోలేము అన్న. ఇప్పటిదాకా మనం టైం యూటిలైజ్ చేసినా, టైం పాస్ చేసినా కూడా నేనైతే ఇప్పుడు ఈ టైంలో వీఆర్ ఇన్ ద స్టార్టింగ్ ఆఫ్ డిసెంబర్. ఓకే, ఇప్పటి నుంచి మచ్ మోర్ యాక్టివ్గా ఉండాలి. మీరు కూడా ఇప్పటిదాకా చదివినా చదవకపోయినా నాకు అనవసరం, కానీ మీరు ఇప్పటి నుంచి జాగ్రత్తగా చదువుకుంటే ఐపీలో 400 పైన వస్తాయి. ప్లస్ నాకు తెలిసి ఫిజిక్స్ స్టార్ట్ అయితే ఒక 1 month బ్యాక్ నుంచి ట్రాక్ 1 సంబంధించి ఫిజిక్స్ స్టార్ట్ అయింది ఒక 1 month బ్యాక్ నుంచే. రియల్ ఎసెన్స్ ఆఫ్ ఫిజిక్స్ విల్ స్టార్ట్స్ ఫ్రమ్ న్యూటన్స్ లాస్ ఆఫ్ మోషన్, వర్క్, పవర్, ఎనర్జీ, సెంటర్ ఆఫ్ మాస్, కొలిషన్స్, గ్రావిటేషన్, రొటేషనల్ మోషన్, ఆసిలేషన్స్. దాని ముందరదంతా కూడా ఏంటంటే ఫిజిక్స్ మీరు ఎలిమెంటరీ లెవెల్లో చదువుతున్నట్టుగానే ఉంటుంది. మోషన్ స్ట్రైట్ లైన్ ఆర్ మోషన్ ఏ ప్లేన్ ఈజీగానే ఉంటుంది. ఓకే, అందుకని రియల్ ఎసెన్స్ ఆఫ్ ఫిజిక్స్ ఇట్ ఈస్ స్టార్ట్స్ ఫ్రమ్ ఎన్ఎల్ఎం అండ్ దెన్ ఫ్రిక్షన్. ఓకే, అది. అండ్ ఇన్ ద ఆఫ్టర్నూన్ విల్ మీట్. ఓకే, most probably by 3:30. Okay, if there is any change, a small change, 15 minutes or 20 minutes, that's it. Okay. ఓకేనా? ఓకే, ఇన్ ద ఈవినింగ్ ఆర్ ఆఫ్టర్నూన్ విల్ మీట్. ఇన్ ద ఈవినింగ్ ఆర్ ఆఫ్టర్నూన్ విల్ మీట్.
సార్ నోట్ చేసుకోలేదు సార్.
నేను ఈ ఫొటోస్ పెడతానన్నా. మీకు ఆల్రెడీ లింక్ పెట్టా చూడండి గ్రూప్లో, యూట్యూబ్ లింక్.
ఎస్ సార్.
ఓకేనా? అందుకని
థ్యాంక్ యూ సార్.
ఓకేనా?
Thank you, sir.